Hello guys, Sohan here, and while writing How Do Computers Work Part 3, I came across a problem. See, the part 3 is all about logic gates and transistors and exciting stuff like that. But people normally don't like logic gates as a subject. So I decided to make a video and make it interactive. Very interactive so that you can build your own circuits and understand this. So let's just start with the explanations and I'll move on to demonstration. This is a circuit simulator made by Ian Sharp, and I am immensely thankful to him for making it absolutely free so I can make this video. So Ian, here goes your karma. This transistor has three terminals: base, emitter and collector. And this NPN transistor enables us to do a simple stuff: switch a higher current with a lower voltage. Okay, let's add some wires. And turn this into a 1 volt source and add another source, connect, and this should work. It works. But how well does it work? Let's add an emitter. Go to draw, active outputs and labels, and emitter. This emitter just measures the amount of current flowing through the circuit. So it should measure, okay, it measures 6.18 kiloamperes. Like, that's a lot. A kiloampere is a lot. If you just don't understand how much it is, it's a lot. Okay, it 6.18 kiloampere. Let's 1 kiloampere can destroy this one. Your mobile charger or laptop charger probably doesn't go above 3 or 4 amperes. Now I can see this, that after adding 1 kiloampere, this current flow falls to 4.9 milliamperes, which is a little less than what I am expecting. Let's add it 200. Now we have 24.26 milliampere, and this one honestly doesn't matter. The higher the better. If I go to 2000, this one falls down, so I can just control it using this one. This is quite good, because if I drop below this, I don't have a significant advantage. If I go to like 100, and it just adds 2 volts, 2 milliamperes. So keeping it higher means this battery will last longer. This one. Now, have you ever seen a circuit with 2 batteries? I guess no. But just to demonstrate that this truly works as I said, let's add a switch. If I turn this switch off, this one shuts down. If I turn this switch on, this one works as well. Off, on, off, on. It's fun. As a kid, I always used to turn the switches off, on, off, on, off, on. Now I understand they would get damaged, so I turn off on here in simulators. Okay. Now we have to somehow make this work with a single battery, right? So remove this whole part, and I also have to make it 5 volts. Okay, I just have to take it somewhere else, a little more. I need a little more space, so I need to have I made this 5 volts? Yeah, I made this 5 volts. Okay, now let's connect this to the emitter. Now add a resistor here. And that's it. I have to also add a switch. Now we can see this one. Here I can use around 10,000 is safe. Yeah, but it's still too fast, so let's add a resistor here. Of 200 ohms, and let's run this one. Ooh. But in a real circuit, you can't just do this one, right? Because you can't see the electrons. You need something to measure, like an ammeter or an LED. Let's add an LED now, because LEDs are easier to find and easier to use. You can use a lot of them to debug. Now this LED turns on, which is weird because you realize this circuit just does a simple thing. Using this switch, it turns on or off that LED, which is weird because you can find a simpler circuit of this by just adding a voltage source, a switch, a resistor, and then LED, and connect this back to the other terminal of the battery. Did I add? I needed a switch, right? Now let's look at this. These two behave identical, right? These two are the same circuits. Then why did I need a transistor to make this simple circuit? The answer is go a little beyond and you'll start to see the power of the transistor. Okay, I'm showing you the power of this transistor. Okay, why am I adding a switch? Let's add a wire, an LED outside this, and connect it to a ground. We also connect this battery to a ground. You can connect it here or here. The wire is the same. It will go through this part or go through this part, but it looks better, so I keep this ground here, and let's run it. The battery is closed, the switch is on, the LED is off. The switch is off, the LED is on. What? You see the power of this transistor? We have just made a NOT gate. It changes the state of the input. If you give it a on, it will give you off. If you give it off, it will give you on. Now let's change it to something little more exciting. Keep it this. Remember this circuit with a single input? What will happen if I added another input? Two inputs, two transistors, double the fun, right? I need another transistor here. Connect the emitter to, connect the collector emitter to this one's collector, and this emitter goes back. I add a voltage source here, connect this to, add a switch. You remember the pattern, right? Then change it to 10,000 ohms, and now let's see what happens. The LED is on if both of these are on. If one of them is off, the LED turns off. If both of them are off, it is also off. So I can say that's 1 1, this output is 1, 0 1, this output is 0, 0 0, this output is 0, 1 0, this output is 0, and again 1 1, this output is 1. This is on. Let's add a ground here. I just undid it. Now let's remember that NOT gate. Let's add that back. Let's add that back. Now this behavior changes because I have effectively added a NOT gate on top of this. Now what happens when you turn one of them, the current takes a direct path from this ground to this ground. The electrons flow through this path. If you turn any one of them, nothing changes. If you turn any one of them, nothing changes. But if you turn both of them, you see this ground is flowing through this, and if instead of taking this route, it takes this route, because this is the path of least resistance. So this is how a NAND gate works, and NAND gate is pretty important. Let's just stop it and just look at what NAND gate is. A NAND gate is a negative AND, and this is a universal gate. So what is a universal gate and why NAND is called a universal gate? So as it appears, we can build any other gates like AND or NOR, XOR, XOR, which are basically the same, or whatever, XAND, whatever gate it is, we can build it using a NAND or NOR gate. Both of them are universal gates, and we can build everything. And in future I will use this software and demonstrate how can we build powerful circuits using this. So for today, that's it. I hope you have understood the working of AND gates, NOT gates and NAND gates. I'm extremely sorry for my poor voiceover skills because I haven't done much, but again, I think you should appreciate me for at least trying. Okay, thank you for now.